Good evening, everyone. In today's lecture, we will discuss accident causation theories, an important topic in process safety and chemical engineering. Accidents in industries do not occur randomly. They happen due to a combination of factors and events. Understanding why accidents occur is the first step toward preventing them. Over the years, researchers and safety experts have proposed several theories to explain the causes of accidents. These theories help engineers identify hazards, determine root causes, and develop effective preventive measures. By understanding these theories, chemical engineers can design safer processes, protect workers and equipment, and reduce the likelihood of industrial disasters. So by the end of this lecture, you should be able to explain why understanding accidents is essential for prevention. You should be able to describe Heinrich Domino's theory and understand the sequence of events leading to an accident. Furthermore, you will learn about other theories such as multiple causation theory, pure chance theory, biased liability theory, accident proneness theory, and energy transfer theory. Finally, you should be able to differentiate between immediate causes and contributing causes of accidents and applies these concepts to improve industrial safety. So first, let us see one by one. What is an accident? An accident is an unplanned and undesirable event that results in injury, death, property damage, production loss, or environmental damage. In process industries, accidents can have devastating consequences affecting not only workers but also nearby communities and the environment. For example, includes chemical leaks, explosions, fires, and equipment failures. Preventing accidents is difficult unless we understand what caused them. This is why accident causation theories are important. They provide a structured way of analyzing accidents and identifying the underlying factors responsible for their occurrence. So accident theories are important because they help us identify contributing factors and determine the root causes of accidents. They give us in developing preventive strategies and improving workplace safety. However, no single theory can explain every accident because industrial incidents are usually complex and involve many interacting factors. Therefore, engineers use multiple theories together to obtain a complete understanding of accident causation. One of the earliest and most influential theories is Heinrich Domino's theory. It was proposed in 1931. Heinrich suggested that accidents occur as a sequence of events similar to a row of dominoes falling one after one another. Enrich identified 5 factors in the accident sequence. So the first one is the ancestry and social environment, which influence a person's behavior. The second is the fault of a worker, such as lack of knowledge or negligence. The third factor is unsafe act and unsafe conditions such as not wearing protective equipments or operating defective machinery. The fourth factor is the accident itself, and the final factor is the resulting injury or damage. Heinrich believed that removing the third domino, namely the unsafe act and conditions, would prevent the accident and its consequences. So the dominoes theory made a major contribution by emphasizing the importance of identifying unsafe acts and conditions. It laid the foundation for modern accident investigation techniques. However, the theory also have limitations. The percentages proposed by Henrich were not based on rigorous scientific data. Furthermore, real-life accidents are often caused by multiple interacting factors rather than a simple linear sequence. Therefore, while the theory is useful, it cannot explain every industrial accident. So the next theory is the multiple causation theory. The multiple causation theory is an extension of the dominoes theory. It states that accidents are rarely caused by a single factor. Instead, they occur due to a combination of causes and subcauses. These factors can be behavioral, such as lack of knowledge, poor attitude, or inadequate skills, and environmental factors such as defective equipment or unsafe procedures. This theory is widely accepted because it reflects the complexity of real industrial accidents where several factors usually interact to produce an incident. The third theory is the pure chance theory. So the pure chance theory assumes that every worker has an equal probability of being involved in an accident. According to this theory, accidents occur randomly and there is no identifiable pattern. If this theory were completely true, preventing accidents would be impossible because accidents would simply be a matter of chance. However, modern safety research shows that most accidents have identifiable causes and can be prevented through proper safety management. The fourth theory is the biased liability theory. The biased liability theory suggests that once a worker has experienced an accident, the likelihood of that worker being involved in future accidents may increase or decrease. This could be due to changes in confidence, behavior, or work practices. However, this theory provides little practical guidance for accident prevention because it does not explain the root causes of accidents or suggest effective control measures. So the fifth theory is the accident proneness theory. So accident proneness theory proposes that some individuals are naturally more likely to experience accidents than others. It suggests that certain personality traits, attitudes, or behaviors may make some workers more accident prone. However, scientific studies have not conclusively proven this theory. Most researchers agree that accidents are usually caused by workplace conditions and management systems rather than by individual characteristics alone. So the sixth one is the energy transfer theory. According to energy transfer theory, a worker incurs injury or equipment suffer damage through a change of energy. For every change of energy, there is a source, a path, and a receiver. So the energy transfer theory explains accidents in terms of uncontrolled energy. Injuries occur when a worker or equipment is exposed to excessive energy such as thermal energy, electrical energy, chemical energy, or mechanical energy. So every energy transfer involves three elements: the source, the path, and the receiver. Understanding these elements help engineers to identify hazards and develop strategies to control the transfer of harmful energy. So according to how to control the energy transfer, according to the energy transfer theory, accidents can be prevented by controlling energy at three stages. At source, hazards can be eliminated through safer design and preventive maintenance. Along the path, barriers, enclosures, and absorbers can be installed to prevent energy from reaching people. At the receiver, protective measures such as personal protective equipment and limiting exposure can reduce the severity of injuries. This theory is highly practical because it provides specific methods for controlling the hazards. The next theory, the seventh theory, is the symptoms versus causes theory. So, this theory reminds us that unsafe acts and unsafe conditions are only symptoms of deeper problems. For example, if a worker fails to wear protective equipment, the real issue may be inadequate training, poor supervision, or an ineffective safety culture. Therefore, accident investigations should go beyond immediate causes and identify the underlying organizational and management factors that allowed the accident to occur. The structure of accidents, the root causes of accidents can be grouped as immediate and contributing causes. A combination of causes must coverage to result in an accident. So the structure of accident can be divided into immediate causes and contributing causes. Immediate causes include unsafe act and unsafe conditions that directly lead to an accident. Contributing causes include management failures, environmental conditions, and physical or mental factors affecting the workers. In most cases, accidents occur when several causes come together. Therefore, effective prevention requires addressing both immediate and contributing causes. So let us compare all the theories at a glance. So we have discussed about different theories, domino theory, multiple causation theory, pure chance, biased reliability, accident proneness, energy transfer, and symptom versus causes. So in domino theory, Henrich identified 5-factor chain. So by removing any one factor stops the accident. No supporting data, and it's oversimplified, the main limitations. And the core idea of the next theory is many contributing factors combine to cause an accident. So the limitation is most widely applicable, it's insight. And the next one, pure chance theory, every worker has equal accident probability, but it has its limitations of accidents cannot be prevented. The next one, biased liability theory, past accidents change future accident likelihood, but it has its own limitations, like it has little preventive value. And the next one, accident proneness theory, a subset of workers is more accident prone, and it is not conclusively proven. The next one is energy, which is uncontrolled energy via source, path, receiver. So three components are source, path, and receiver. So the main key point or limitation is it guides practical hazard control. The next one is symptom versus causes. Main is one is the unsafe act or conditions are symptoms but not root causes. Push investigation deeper. Each accident causation theories provides a different perspective. So the domino theory emphasizes on sequential events. Multiple causation theory focuses on multiple interacting factors. Pure chance theory considers accidents random. Biased reliability and accident poorness theories focus on worker characteristics. Energy transfer theory explains accidents through uncontrolled energy, while symptoms versus causation theory emphasizes root cause analysis. Together, these theories provide a comprehensive framework for understanding and preventing accidents. So to conclude, accident causation is a complex subject and no single theory can explain all accidents. Each theory contributes valuable insights into understanding why accidents occur. By combining these theories, engineers can identify hazards, analyze risks, investigate incidents effectively, and implement preventive measures. In chemical industries, understanding accident causation is essential for protecting workers, safeguarding the environment, and ensuring sustainable and safe operation. Accidents do not happen by a chance. They occur due to a combination of factors. Understanding these factors is a key to prevent future accidents and creating safer industries. Thank you.